Hello, in this video I'm going to be taking a look at the Mbed OS online IDE, which is a very nice way of writing and compiling programs for these little STM32 ARM processors, and I'll be looking at how you can install one of those programs on each of these 4 development boards that I have here. And if you're going to do this for some of these boards, at least you'll need this ST-Link thing as well to write the program to the board. So this video is mostly going to be useful for people who are already familiar with Arduino, but they want to get into STM32 programming as well to make use of the faster processing speed and higher memory limits and so on. So I'm not going to be explaining anything like what is a serial connection or what is I2C or a digital out or an analog read or anything like that. I'm just going to assume that you know that kind of stuff already from your Arduino experience. So this is where you would go to get started, os.mbed.com, and there's a get started button there, so you would click that and go through the account setup process, and then you would be taken to the compiler screen, I think. Now I've obviously already done that and I'm signed in here, so I can just click on compiler. I think I'll just open that in another tab actually. And then after a little bit of loading we'll be shown this program workspace where you can see all of the programs that I've been working on already. And there's some buttons up here, including one that says compile. So the whole idea with this being an online IDE is that the program is compiled on the server, and you don't need to actually install anything on your own computer. So as you can see, I'm just running this in the web browser, which means it's going to be the same on Windows, Mac or Linux, wherever you can get a decent web browser. I'm using this in Chrome, which works really well. If you used online IDEs back in the day, they weren't very good, but this one I find very pleasant to use. I haven't tried Firefox or any other browsers, but I do know that Chrome works very nicely. So it's great that you can just use this anywhere. You don't have to have it installed on the computer that you're using it on, which is really good. Another thing which is pretty cool about having all of your source code sort of stored on the server in this sort of a repository or program list or whatever you want to call it, is that it's very easy if you want to make your code available to other people. All you have to do is, I think you can like publish or something like that. It's been a while since I did that, but if you publish your code for other people to see, it'll show up in this sort of a list, and you could do something like, is there something for GPS? GPS OLED, hello world. Okay, so let's click on this guy's thing, and come on. So we can see some of it's in Korean. So he's actually documented that quite nicely. That's good. Yeah, alright, so down here we can see the code that he's used, but more importantly, if we just want to bring this into our list of programs, we can just click on here, and then that will show up in my list and I can work on it, sort of like cloning from GitHub, except it's not source control, I don't think. There probably is something to do with source control in here as well, I don't know. But anyway, it's a really nice system to have it all online like this and just ready to go anywhere on the planet, basically, wherever you have a web browser. The downsides are, of course, that you do need an internet connection to make any of this happen. So I think in this day and age it's not really that much of an issue. But another issue that you might want to consider is that there's probably somewhere in the terms of service of this website, I did not check, but I would imagine that they say that whatever you code in here is going to be belonging to them, or in some way that you can't keep it completely private. They will have access to it, obviously. So if you want to make a commercial program that's going to be closed source, you might want to think about using something other than this kind of system. But I think for the hobby programmer like me and you, that none of that should be an issue. Alright, so to make a new program of your own, you would right-click on the My Programs section and do New Program, and then you would be asked to select the hardware or the board that you want to run on. And to begin with, I'm going to start with this Nucleo F401RE, which is this one here, because that makes things quite a bit easier than some of the other ones, because it has an onboard ST-Link thing and you can output printfs directly to USB and so on. Then select a template, and I'm just going to go with a blinky LED test. There's actually another one there, I'm not sure which one I had. And then you would give it some kind of a name and click OK. I'm not going to do that because I already have one here, but after you do that you would see something like this. So you'd have this main.cpp, which is your own code, let's call that, and then this other thing, which is the embed operating system, okay, I guess. So in this one here, classes, we'll see some terms that you should be familiar with from Arduino. So we've got analog out, analog in, we've digital in, digital out, and then we should have I2C there. And do we have SPI in here? Yeah, SPI. Serial as well. So we're going to look at some of those in this video, but basically the way things work is that most things in Mbed OS are a class. So I2C would be set up as a class. Actually, let's click on this and we'll look at some of the documentation. So you would construct a class like this and give it the SDA and SCL, which pins you want to use, for example. And serial, you would do something similar. So you construct it like that and you say TX and RX pin, and then optionally you can also say what baud rate you want. You can set the baud rate with this function here like that, check if any data is available and so on. So pretty quickly you should see some parallels to what you're familiar with in Arduino there. What might not be quite so, it's kind of similar I suppose, is that this method of making a class with a pin parameter is also used for, even for simple things like digital in or digital out. This is what we're going to be using for switching an LED, blinking an LED off and on. So we have a digital out class, and then we'd say what the name of the pin should be. Notice that this is a name, it's not a number. Well, it is a number, but it's a, well, we'll see. You'll see what I mean in a minute. Anyway, so let's go back to the code that we had there. So to do the blink sketch, we have this thing here. So there's the class that we just saw, digital out, and we're going to instantiate an instance of that class called myLED using pin LED1, and then we have this loop here that just sets it to be 0 or 1 and then waits 1 second in between. So to compile that, I'm going to click on there. Actually, I'll just show you a little bit about these boards that I have here first, because they are slightly different, and as I said, this one makes things a lot easier than these other ones. So let's start with this one. This is made by ST, produced by ST, as some sort of an educational board, and it actually has a section at the top here which includes the functionality of one of these things, which is why I'm able to plug my USB directly into here, and that will power it and also translate the instructions to flash the program onto the main chip, which is this one. So it actually has, this chip here is the same as the main chip on these boards, I think. I forget what they are exactly, but I think one of them is the same as that. Anyway, so this is an F4 fairly capable chip there. It's got lots of inputs and outputs and all that kind of stuff. So I think it's this little LED here that we're going to be turning off and on. So let me just get that plugged in. Oh, it looks like that's just a power LED, so it must be the other LED there that we're going to be turning off and on. By the way, these jumpers here have to be in a certain position if you want to use this ST-Link section here. So you can see these two jumpers here. It says Nucleo on there with the closed symbol, and ST-Link with it open. I think Nucleo is what we're about to do, in that this section here sets itself up as a disk when you plug it into the computer. So if we look at my, where is it? Oops, here we go. So this is my File Explorer, and you can see that I have this plugged in, and it kind of looks like a flash drive when it shows up. And if I click on there, it just shows me some stuff here, which I don't think you can really do anything with that. But what's really neat is that when you compile the program, all you have to do is plop it into this folder, and the program will be updated, and this thing will reset, and it will start running your new program, which is pretty cool. Oh, by the way, I said that you don't need to install anything on your own computer if you want to get this to work, but I think for what I just said, if you want to have this thing showing up as a flash disk and put the program on there and have it automatically reset and everything, I think you do actually need to install some drivers. At least on Windows I had to install some drivers. But for this other stuff, I think, do you need a driver to use this? Maybe on Windows you do, I don't know. So Yeah, sorry about that. There may be a little bit of setup that you need to do to get this talking to your computer correctly, but it's not much compared to what you have to do for some other things. Anyway, so let's put a program onto here, go back here, so I'll click compile, and just check when you're compiling if you're doing this for multiple targets. I'll just double check that I do have this set to Nucleo F401RE, and if I click on here I can change it in a minute. And you can see the ones down here, it says your registered platforms. Don't worry about the word registered, that you don't have to pay for anything in any of this. These are just the ones that I've been using in the past. And if you click add board, I think, is it add board? Let's see what this does. There's a huge list. Alright, so all of this stuff here you can select as a target, and this Mbed OS will know how to build a program for this. Quite a bunch of them. So wonder if that, I don't think that Maple Mini is on here, but anyway, so all of their OEM boards, or whatever you call it, the ones that they make themselves are on here obviously, but there's a bunch of other ones as well. Anyway, so you can choose from there and just make sure you have that set correctly when you come to compile. So let's compile. And if there's any problems, it will show you in that section down there. Obviously no problems at this one. So what I want to do is make sure I have this selected, and then just why is this so big? I'm just going to click save, and hopefully, there we go, so it's green. I was only doing this yesterday. How could I forget which LED it was? Anyway, so you can see that that's switching off and on at 1 second. So that's the blink sketch. Let's have a look at next sketch, which is just showing how you would use serial. Now, once again, I'm going to be doing this on this Nucleo board, which makes things a lot easier. And one of the things that it makes easier is that you can set up a serial connection, and they've just called it PC because it's going to be talking to the computer, and the TX pin is going to be the one that's named USB TX, and the receiving pin is USB RX, and it's going to be running at 9600 baud, and it's just going to loop printing hello new line every 1 second. So again, I can compile and run this, or compile and download. That's better. Why is it? So just check that it's on there, because if you unplug and then plug in the board again, you'll find that this this path that you were using last time will get reset to something like home documents or something that's not right. So you just have to double check that it's in the right place each time. Anyway, save. So that program should be running now, and you can see that my LED is no longer turning off and on. So I think the new program is running. As for how to look at that, I think we should have. Okay, so on Linux at least, this Nucleo board, this white board there, is showing up as dev TTY ACM0. So I can look at it through here. This is probably the easiest way to do it. Port ACM0, look at the serial monitor. Oh, that doesn't look too good, does it? Huh. I've noticed that every now and then, probably about once every three uploads, it doesn't seem to upload properly. This one has a reset button on it there, which I'll give a push. See if that helps. No? Alright, well, if you find that it doesn't work, just do this again. Oh, that's interesting. Look at that, the old file is still there. I notice this problem sometimes too. Hey, save. Yes. Oh, it doesn't want to do it. I have had this problem. So usually what fixes it is plugging it in again and then I'm probably going to have to. I also found that now that's not available, is it? So it's not entirely smooth saving. So it's ACM smooth sailing, that is. Dev ACM1 now. Port ACM1 serial monitor. Still nothing. What the hell? What's wrong with this? Alright, so we finally got it working. See, it is a bit fussy for some reason. It doesn't always require that. I'm not sure if I should leave this in the final video because it's a bit long and boring to watch, but maybe I should, because it does demonstrate that if at first it doesn't work and you can't see anything obviously wrong in what you've done in your code, just try uploading again or unplugging and replugging. In fact, this system here where you put the file onto it like a flash disk and it sort of reloads and resets itself gives me more problems than what I have with these other ones where you use the ST link, if that's any consolation. Anyway, so now we have printf. This is just PC printf. So that's a serial connection. Now on the other boards that I use, we can't do this because we don't have this sort of a special section over here to do all this translating to talk to the USB directly. So if you wanted to use serial output for some of these other ones just to debug with or something, what you'd have to do is output it on one of these pins here, and we'll figure out which pins it would be, and then you would have to use an FTDI adapter, something like this. Get out of the way. You'd have to use something like this to listen to it and then display that on your PC. I think I might just do that actually. So let's look at one of these other ones, and my favorite one has been this one because it's nice and compact, and as you can see I've sort of semi-permanently connected my ST link thingy to there because I've been using it more often than the other one. So this ST link thingy needs a ground, which is my blue there. Now let's just get that stuff out of the way. Might be a little bit hard to see. Oh, there we go. So we've got VCC and ground. These need to be 3.3 volts, the VCC, for these things. And you can see it's actually written on there. There is also 5 volts on there, so watch out for that. You should use the 3.3 volts. And then the trick with these is trying to figure out which of these other two pins are the data I/O and the clock. So if we look at green and yellow here, we'll see that yellow is data I/O and green is clock. So as to where they need to go on each of these other development boards, if you can figure that out, then you've solved half of the problem of how to use this Mbed OS with just sort of any generic development board. The other half of the problem, obviously, is to figure out what target you should use in that big list of boards that we saw just before. So I have figured out that this Nucleo F103RB has been working for everything that I've tried on this Maple Mini. That's the Maple Mini there, and Maple Mini. And also this board here, which is a very, very similar F103 something something chip. So they're very similar boards, and yeah, the F103 Nucleo target has been working for both of these quite nicely. It might not work for every single pin that's available, but everything I've tried so far, it works pretty well. This one over here is an F407 VET6. And this is a really nice board. It's still only about $10 or so. These other two are about sort of $3 or $4, by the way. This one's twice as much at $10, but it has some really cool features. So I might look at that a little bit in future. maybe not in this video so much, but in future videos. So let's set up this one with a serial connection, and well, let's look at the pinout and we'll see why did I put clock and I/O on two pins 21 and 22 there, and where should we connect, or where should we try and connect a serial output to listen to it. So to do that we need to do a little bit of Googling. Alright, so I googled Maple Mini pinout, and fortunately this one's a fairly well-known board, so the result was easy to find, and there's some really nice diagrams. This is a pretty nice one here, and what we're looking for is some way to match up the functionality of these pins. For example, we've got serial TX and RX there with the port name and pin number. So we've got port A pin 2, port A pin 3. Over here we have another serial, the same one there. We have I2C on those pins there, I2C2 down there. So for example, in our program later on, when we want to set up an I2C class, we need to say, if we want to use this one, we need to give it port B pin 10 and port B pin 11 as the SCL and SDA pins to use. So obviously you can see why this is quite important, and it's once you get a diagram like this, you're set. You shouldn't have any problems after that. Now what we were looking at just before was like where we should connect the clock and data I/O pins to actually write the program to the chip. So you can see here pins 21 and 22, they're not labeled with this stuff. A lot of these pins are actually labeled quite usefully on this particular board, but some of them are not. In this case the clock and data I/O were not labeled, but this diagram lets us see that they are on 21 and 22 on the actual screen print on the board. And we may also, I found it useful to know that these are PA14 and PA13, because on this other board here nothing is quite so nicely labeled, but I just took a chance on the fact that this CPU and this CPU, or these chips that are on them, are very, very similar. I thought it's probably PA14 and PA13 on there. So you can see for this one I've connected my green is clock and yellow is data I/O, and I've connected those to PA14 and PA13 on there. And I don't think I'll demonstrate any flashing to this one in this video because it's probably going to get too long, but basically it works the same as this one once you've figured out which pins to use to flash to. Alright, so let's first just make sure that we've got everything working. I'll go back to here and I'll go back to my Blink program, and I'll change it to, I'll change the target to this Nucleo F103 RB like this. Check that that's what we're using now, and I'll compile this now. Because I don't have this fancy system where you can just drop it onto the file system and it reboots the board and uploads the program, what I'm going to have to do is download it somewhere and use the STFlash utility to actually flash it. So it's giving me this file, and I'm going to put that in a folder called binaries there. And I guess you do need to have this on your computer, don't you? Sorry, I forgot about that. I have this utility on Linux, of course. You can probably get the equivalent thing for Windows, and you do stflash write, and then I should have only one file in there now. So this is my file that I'm going to flash, and then that address there. I don't think there's any occasion where you would use a different memory address, but let's just get some of these windows out of the way. Alright, so let's flash that. And with a bit of luck, see again it didn't work. It should be flashing. Oh. I wonder how many of these goof ups I should leave in. See, what happened there was LED 1 is port B pin 1, but in my program I'd left it at LED 1 for that other board. So what I should have had is port B pin 1 like that. Alright, compile, and then I'm gonna it tries to put this brackets 1 on the file, but I don't want to do that, so I'm just going to save it as the same name. Let's try that again. Alright, so now we have the Blink sketch running, so at least that lets us see that we are talking to the board properly. because the serial out that we're going to try next is not quite so visible. So let's also change this serial sketch to use that target. Compile it. Oh, I screwed up again, didn't I? Alright, I'm just going to cancel that. So my screw up was that I'm still using USB TX and RX, which will not work for this board. So let me just check what... so we have serial 2. Yeah, let's try this one. So serial 2 TX is PA2. Serial 2 RX is PA3. So PA2, PA3. And if you click on here, it will actually show you some documentation for each of these classes if you forget which order the parameters go in. So PA2, PA3, TX and RX, right? PA2, PA3, yep. PA2, PA3, 9600. Alright, now it should be okay to use. So I'm going to call this one O2 serial, like that. And I'm just going to flash that. So it's going to be called O2 serial, like that. Boom. Okay, so there's nothing to look at now. But let me just get my FTDI adapter connected, and then we can check that it's actually giving us some output on those serial pins, which are, let's see, we have serial 2. Where is that? So it's this TX2, RX2, so it's pins 9 and 8 on there. And I'm going to be plugging into pin 9 because all I'm doing is listening here. So I just want to listen to what's coming out on the TX pin there on pin 9. Okay, so I have my FTDI adapter connected to the board now, and that's just connected by ground and RX to TX on there. And I'm going to power this board just from a USB power bank because the program is already on there. All it needs now is power, and also because my webcam is using the other USB plug and I don't really want to unplug that. So, and we need something to look at this with too, don't we? So let's go back to Arduino again. I mean, you can use other things to view serial connections like this, but Arduino is one that I suspect a lot of people watching this video will already have available. So we don't see anything yet, but it's because this is not turned on. And now we should see some hellos. And when I turn this off, that will stop. Alright, so that's how you can get some debug output from one of these things. So to finish off this video, I have an I2C example that I wanted to show you as well, and I think I'm going to go back to this board to do that with, just because it's a little bit easier to record the video with, because like I say, my webcam is using my other USB and it's just awkward if you have to have an FTDI adapter on there as well. I wanted to look at this a little bit too, but the video is getting a little bit long, so I think I might look at this a little bit more in future. But basically it's the same. You just have to figure out 3 volt 3 ground, and then which pins are the clock and I/O there. And to do that, I'll put a link in the description to this page here, which has a ton of information. I wish this was around when I bought this board about 2 years ago because it's a really neat board and I would have done a lot more with it if I had had all of this detailed information. So the detailed information I'm talking about is down here. So you've got the data I/O and clock on that port there, or that plug there. Just pay attention to the way they've drawn this. So this dot here is drawn on one of these pins that comes up out of the board. So it's the bottom row on there is the bottom row on there, if that makes sense. Anyway, I think you'll figure it out. Yeah, so this board is really neat. You can see here it's up to 168 megahertz CPU, 512k flash, and what drew me to this originally was the 12-bit ADC and DAC, and also a large amount of RAM, 192 kilobytes of RAM. So we may see this featuring in a future video, possibly, I don't know. Anyway, so I'll just put that aside. It's the same as everything we did for this one, basically. You just have to figure out what port and pin number to use, and you're away laughing. Oh, wait a minute. You won't quite be away laughing until you figure out which target to use for this, but this guy has kindly told us. I actually figured this out on my own just by trying a bunch of them, which is why I was saying I wish this page here had been around 2 years ago. But anyway, create a program as if it was for a Seeed Arch Max board. I think there's actually 3 E's in there, but what he's talking about is this target here, and it's this one. Yeah, there's 3 E's in there, eh? So if you use that one, you'll be able to compile programs for that F407 VETX board. Anyway, for those of you who kindly had enough coffee to make it through to this point without falling asleep, my little I2C demo that I wanted to do was using this magnetometer, or compass, and this is a typical HMC 5883L that we have on our drones quite often, and it's just using an I2C interface there, so it's just those 4 pins, VCC, ground, SCL, and SDA. Now on this one here, I'm going to go back to this one just because it's a lot easier to show the serial output on the computer. Up here in the top right corner we have 4 pins which are very conveniently the same pin, same functions, ground, VCC or VDD, and then we've got SDA and SCL, so looks like there's an I2C there. And in the case of this particular board, or these Nucleo boards, I'm pretty sure you can use these names here, D14 and D15, and you can just type that straight into your program as the name of the pin there, and it will work. I didn't actually check that. I think I checked it with one of the serial ones, but just in case it doesn't, or just to be a little bit more generic with what we're doing, I'll look at this page here, which is the page for this board. And it's very well documented, and right about here was the section we just looked at. So we have ground, VCC or VDD, which I think means the 5 volts rather than 3.3 volts, whatever. And then we have I2C1, SDA, and SCL there. And we also have the port naming like that. So this is why I called these names rather than numbers. So you can give them a name, and they're all synonymous with the same integer pin number, I guess. Anyway, so PB9 is SDA, PB8 is SCL. So if I just switch over to my third example, which was here, so this is I2C, and we're going to be, oh, it looks like I did try D14, D15. Okay, so that does work. So either of these will be the same, I think. So I'll just, tempting fate here, but I'll just switch to the port names one, PB9, PB8, and when my cursor is on this I2C thing, you'll see that this shows up just to remind me that they are SDA, SCL in that order. And then I also have a serial connection or class to let me print something back out to the computer. And this is a very simple program. It's a little bit, I'll just stretch the screen out a little bit because the whole program should be able to fit on there. There we go. So all it does is it writes these 2 bytes to the compass at the beginning, and I think what this does, I can't remember, it's a while ago I did this, but it sets it into continuous mode, so it's continuously measuring the magnetic field that it sees and writing or continuously doing something, continuously reading the magnetic field, I think. And then in this loop here we are going to send a command, which I think this doesn't really matter, but whatever I2C device you're using will be different. But the point is, you just call I2C write and read like this, and this class will handle all of the reading and writing for the device that you're doing. And let me just have a quick look here. I wonder if you could change the speed for this I2C as well. I2C. No, so we've got stop, write, read. Oh, frequency. There we go. Look at that. Easy. See, in Arduino that's not quite so easy, but here it looks like you can just call this and set the frequency for it. Nice. Anyway, so this is the target that I wanted for that, and I will just compile, and, well, let me plug it in first. Alright, so that's all plugged in and ready to go now, and I just compile, and since we're back to this user-friendly one, all I have to do is drop that file into this location, and then I'll go back to my Arduino and see if we get some output. Oh, so I've kind of skipped over the rest of that code there, but once we've got that output from the compass, we just do a loop where we print each of the bytes that we got. So we're reading 6 bytes, and the pairs of 2 bytes that get stuck together like that to make one integer. So there's 3 integers, there's x, y, z, and then we're just printing the x-axis out there as the amalgamated number like that, and then we're waiting half a second. So let's see, hopefully we get better luck with this one. SCM0 serial monitor. Alright, there we go. So it's running, and just so that we can see that it's actually doing something. So we should see those numbers changing a bit when I move it around. Not changing much. This axis. No, which axis is... I don't know. And just to make sure that we are dealing with magnetic field rather than a gyroscope or an accelerometer, when I put this metallic ruler next to it, we should see those numbers change as well. Wow, there we go, look at that. Let me take it away, it should go back to about whatever it was before. Anyway, it's probably more than you wanted to know, but suffice to say that this system is really, really cool, and I will probably be using this as much as I can for any STM32 related development that I do in the future. So you may see a little bit more of this on my channel going forward. Anyway, that's all for now. Hope that was useful, and thank you for watching. See you next time.